So, hi, I'm Dustin. I work for Bloom Credit. I'm an engineering manager there, and we're going to talk about JSONata. I'm not sure if any of you guys have heard of JSONata. If any of you have, please raise your hands. Okay, the three people I expect to raise their hands know about JSONata. So this talk is how we use JSONata, which is just a declarative expression language that works on just JSON documents, and how we used it to tackle messy credit data that we ingest every day at Bloom. Yeah, that's me, by the way. This is my first talk I've ever done, so bear with me. Yeah. So we'll get into like why credit data is actually like super messy. We have three big bureaus today. Like you have TransUnion, Experian, Equifax. They all have different formats. It's all roughly JSON data at the end of the day, but different field names, things like that, all represent different things. And if you've worked with it, you know how messy and how hair-pulley it can be, just trying to deal with three bureaus and combine them into one. You have deeply nested fields and consistently named stuff, and for the most part, a lot of it's undocumented. So what we're trying to do is to extract meaningful signals. So some examples of that is like payment behavior or like utilization of different bills and things like that. So that's kind of where we landed with JSONata, is like maybe we can use this to address that problem. So for this example, like we want a set of clean credit data attributes. Some of them are total open revolving balances, all the stuff that's up there, and number of delinquent counts, and there's a bunch of different use cases for the metrics we would pull from this. If you think of like underwriting decisions, dashboards, ML models, tons of different things you can use this data for. And at Bloom, we use it for a multitude of things similar like that. So that's basically the problem we had. This is the solution we wanted to get to, and we ended up jumping on JSONata. You may be thinking, like, why can't you just write this code in whatever language you prefer? We're a Go shop at Bloom. Imperative code is kind of rough when you start getting into like really large JSON documents. So for example, here you have 5 lines of imperative code, right? That's just looping over an account, looking for statuses and open. So we typically end up writing 10, 20, sometimes even 50 lines of code to like derive these attributes. As you can see, like as your code base is growing, it's going to become hard to read, hard to test. You'll end up with like a bunch of nasty loops in there. With JSONata, you can basically just use one line, and this side-by-side example I think is like one of our more or less like real-world examples that we've used at Bloom today to show like how you can essentially refactor or clean up the code with like a single line of JSONata. While there are different like libraries depending on what language you use, there's a pretty like, I would say, complete set of SDKs available to like basically write your one line of code like you see here on the right. But yeah, so the left is exactly the same thing as the right, just one uses JSONata, one doesn't. And then this is like I guess this is where we hype JSONata up, right? It's a query transformation language for JSON. I described it to some of our engineers as, think of it like SQL for deeply nested objects. The reason we really liked using it was it's expressive, readable, and it was, I guess, ironically built for exactly what we needed to do, is just turn unstructured, or rather structured, messy data into something we can hand off to business ops and things like that to derive actual insights and meaningful decisions from. So I'll go over like some quick JSONata basics and things like that, and then I'll jump into like a real bureau JSON sample that I've modified and taken from our database and kind of showed like how we use it internally at Bloom. So JSONata basics, if you look, you'll see that the syntax is like honestly kind of similar to any, what do you call it, like a SQL query language or some ORM, filtering, aggregation, mapping, and conditionals, same thing. It's pretty straightforward. There's not much to explain with that. And then here's our real bureau sample. This is just synthetic data modeled after what you might get from a like TransUnion, Equifax, or Experian query. It's nested. You have arrays. If you can imagine like multiple accounts in there, and then under accounts you have more objects, it could just get like 4 or 5 levels deep. So this is kind of what we're going to tackle. So the first pattern I'll go over is filter and aggregation. This is kind of like that first example I showed you. This will filter for all open revolving accounts and then sum the balances, and there's no loop. So like this is what I personally wanted it for when we first looked at JSONata. We would have to loop a lot in our code base, and we used this one line to basically get rid of insurmountable amount of loops. The next pattern we'll jump into is conditionals. It's like pretty straightforward. You can embed business logic right into JSONata, which is a pretty unique feature and pretty helpful. We're in this exact example, we're scoring each account based on a balance, and you don't have to like pre-process anything. You can just grab the balance object from your partner object and sum whether it's high or low. Obviously this is like super simplified in terms of high or low, but you can see how you can write custom business logic around this to basically say what you need it to say. And then time-based logic. So if you're working with, for example, at Bloom, we do a lot with like payment history profiles and things like that, where whether or not you paid on time is a big deal to us and how we report to the credit bureaus. Having time-based logic is pretty cool. It's really simple. They have the now function, which makes time super easy, and then you can just run actual mathematic or arithmetic on the actual time object in your custom object. And then reusable functions. So this kind of goes back to like the whole thing of like keeping your code clean and how JSONata does that for you. You can define a function and keep using it throughout the code. We use this to basically just say like, hey, if you were to take like the time-based logic function and you want to use it across different areas of your code base, you can create it as a function and then just keep calling it and calling it and calling it, and then you don't have to keep repeating it. And then you're back down to like 2 lines of code instead of in Go being 5 to 10. And then you have custom composition. One thing you'll notice is like all these are one-liners, which is to me the cool part about it. Prior to Go, I worked in like Python only, so like one-liners are kind of like just built in to like what I want to do. Although Python doesn't necessarily make them human readable, these seem fairly human readable. But this gives you all the average balance across all the installment loans that we would have on our accounts object. So you can basically choose a big array and grab a field from that array, array of objects, and then average and balance and run arithmetic over all of them in a single line, which is really cool. There's no need for like nested logic or conditionals to build like a complex expression. Yeah, so cool. That's that. We'll go to scaling JSONata. Sorry, didn't want to do that. It's generally fast. We use it in batch jobs. We use it on our APIs, and you can test it. It's embeddable, and it's deterministic. So scaling is generally fairly simple. It's just done for you because of how easy it is. The ways that we, I guess I would say some like internal rules that we use for JSONata at Bloom is to keep your expressions pure and simple, abstract repeated logic, and treat JSONata like code. So avoid over nesting, use reusable functions. The biggest thing now is with like this whole AI wave, a lot of the, like if you use Copilot and things like that, a lot of code review tools will actually pick up on a lot of like what I would say are like messy code examples that exist in JSONata. And here's some like downsides, because not everything's perfect. You have, if you keep writing JSONata and you focus on the one-liners, you may start running into some issues with debugging. It does have some trade-offs. It is read-only, so you can't really have stateful operations, and you have to like kind of watch your nulls. But if you're writing in Go, you're generally just aware of nulls anyways. But more or less, it's a thing to watch out for. Now you have some alternatives. With that being said, I've never personally used JQ, but raw code versus JSONata, there's like just a quick example. I'm not sure if anybody has any experience with JQ or not, but if you do, tell me if this is wrong. This was just from me like trying to figure it out. I would say, so yeah, the summary on JSONata is basically lets us build credit logic that's readable, composable, and production ready. With the right patterns, you can go from raw JSON to, I guess I would say, production ready expressions pretty quickly. And if you start writing JSONata, like there's a lot of cool resources out there. I hope this works. It should. Ooh, it was the wrong link, but that's okay. This is basically an example of like a JSONata playground, and you can write here. So when we first built out, or when we first, I guess I should say, POC JSONata, we were looking at this website, and we were putting some test data in here and just testing a bunch of stuff, and you can basically see how you can get the account order across this entire object. Super cool playground, super helpful, and I would say like the maintainers of the repo are super responsive. So yeah, that is like the quick like resources I have. That was really fast. I apologize. But I do have, if you guys have questions, I'm happy to answer them and talk about JSONata if you guys have used it. If you guys have used JQ, happy to hear about anything related to it, because JSONata is still new at Bloom, and we're still learning a lot about it as we are like working with it. So I'm here all week and happy to answer any questions. What's up?
Yeah, were you doing everything in raw code before, or were you just working the operations at all?
We were doing everything in raw code before. So our process before, albeit not the best, would be like very like on demand, right? So whether it was, hey, could you run a query to grab, let me think, all open accounts for this organization that we have, right? And then it would be like, can you now filter down into accounts that haven't made a payment in the last 30 days, right? Like you see how like it was basically like, can you do this? And then it was like ops were like, wait, can we go this? And like keep going layer down. And so what we did now with JSONata was we have started to basically take that out, and as we are writing, I would say, to further our goal of automation and to keep our developers developing is the way I'll phrase it. We have tried to extract a lot of that, and what we did internally was we have now, I'm not sure if you've heard of Redash before, similar to Metabase, other tools like that. We have basically used JSONata to extract those business queries that are asked quite frequently into a Redash dashboard. And instead of writing raw code to power that, it's now one line of JSONata, and then we can share our business ops code with our actual main code base, so we're not maintaining two different, I guess I'll say like metrics. Yeah, it's been nice. As someone who's written when we first started was writing like the 500 line Python scripts to generate a PDF or something like that. It's very nice. Anything else? Cool. Thank you for listening to me talk for all of 17 minutes. I appreciate it. I think we're probably on 5 months now, about that. Does that sound right, Essler? About 5. Like, yeah, 5 months in production. It's probably been closer to like 6, 7 not in production. It was, we kind of did, something we do at Bloom that I actually enjoy is like we try to do like quick POCs like on just random stuff. So like if someone has like a self-start thing, that's awesome for us because like we'll just like go set it up and run it to the very end and be like, okay, cool, like here's our enterprise contract, like we'll figure it out. But we did that with JSONata. It was like, let's just try it, see if we could get it to work the way we wanted to, and it did. And we're like, sweet, let's just move it to prod. Yes. Yeah, so I have notes on this. Please hold. Yeah, basically, if you have if you think of like JSON where like, depending on, once again, this kind of goes back to the bureaus, if they don't return like a standard for a null value, so for example, think of, like if it's an int, some people will just return 0, right? And that generally means null. Unfortunately, they're not the same. So some will just not have the field. Some will just have an empty string. Some will just have nothing. I've actually run into just a hard-coded number that just means null. So like 4. And you're like, all right, well, that is something. So the idea is like if you're not validating the JSON document coming in, you may run into those issues. The way we handled that at Bloom is like, if you think of us as like an aggregator for all 3 credit bureaus, what we do is like we've come up with like what we determine our Bloom model is. So it's basically a more developer-focused and developer-built model that kind of combines them all into like one that makes sense. And then we obviously follow the best practices for like JSON and APIs, right? So if you use Bloom, you generally don't have to worry about having like 4 meaning none. And that's kind of like just checking for those null values and being weird. So for example, when you're working with credit data, sometimes you'll get a credit score back that's like 0, but the human's real, that's not a thing, right? So it generally is like no credit data, they could be deceased. There's literally a list of things, and it generally requires you to go back and talk to the bureau that returned that data, because TransUnion, Equifax, and Experian all have different ways of handling it. So what we've done is kind of like map that on the back end so that if they are deceased, you're just be like, okay, that's fairly obvious. Like you don't have to go and talk to these 3 bureaus to figure out where this person is. But yeah, so that's the null issue. Yeah, I think that's a fair way to phrase it. Yeah, like null itself isn't an issue as long as you validate the JSON document, right? But the meaning of null between the bureaus is different, which would cause an issue. 21 minutes. All right, you know what? 50%. Appreciate the questions. Thanks, guys.